Bismillahirrahmanirrahim. Mr. Sophia Suhail is here. The topic of this video is second order derivatives. First, I make a number of videos regarding the differentiation topic. Okay, this is a specific topic which I have selected from the exercise 2.7 of the class 12. But these type of questions are very common in the A levels also. Okay, whenever you are taking the first derivative, in the same way you can take the second derivative also according to the same rules for the differentiation. Just we have the function y equals to cos inverse of x whole square. Okay, then to take the proof or to find out the proof, what we have to do, we must have to take the second derivative, y2 means second derivative and first derivative, then we have to prove this one, means this is our required formation to make. Either we can make the formation equal to this, or we can find out second derivative, first derivative, then put in this equation and prove that it is equal to 0. Let's go for that one. Differentiate with respect to the variable involved with respect to x. As the variable is x, so differentiation will be done with respect to x. D by dx of y and d by dx of cos inverse of x whole square. When whole square is used, so obviously we have to apply the power rule for differentiation. Power rule I have explained in my separate video also, you can check from there. Power rule we will use. According to power rule, power will be written in the start. If you have whole power on a function, power will be written in the start, then power minus 1, as it is function power minus 1, and derivative of the function under the power, that is cos inverse of x. Okay, now 2 as it is staying cos inverse of x power 1, no need to write that power now. Okay, derivative of cos inverse. What is the derivative of cos inverse of x? That you have to learn. Before that I have done the video regarding that for the derivation also. That is 1 over 1 minus x square, square root. Okay, excuse me. And the derivative of the angle, derivative of the angle, if the angle is only x and we are doing the differentiation with respect to x, then mostly we are skipping this part also, because its derivative will become equal. But if you want to write, you can write this portion also. This is dy by dx. As we want in the form of y1, so we can write dy by dx as y1 also. So y1 is equals to negative 2 cos inverse of x over 1 minus x square, square root. Now this derivative is done. First derivative is ready. We can highlight our first derivative and name it as equation number 1. Now as we have to take the second derivative, okay, so take derivation again, means derivative with respect to x on y1 and differentiation with respect to x on this function. And this function minus 2 cos inverse of x, if you want to write as it is, you can write. But if we are writing as it is, we have to apply the quotient rule. And if I am taking this function up, so its power will become 1 minus x square, whole power will become negative 1 by 2. Because its power 1 by 2, on going in numerator, its power will become negative 1 by 2. Then we have to apply the product rule, and I think that product rule is comparatively easy to apply as compared to the quotient rule, so I will go for the product rule. Okay, this will become second derivative. Minus 2 is a constant number. Okay, so first term as it is, derivative of the second term, that is 1 minus x square whole power minus 1 by 2 plus first term, second term as it is. By mistake I write plus, I will make it minus. Derivative of cos inverse of x. Okay, now you know that this minus 2 I kept outside. This minus 2 I kept outside, so it will stay outside for the whole function. Okay, so now minus 2 staying outside, cos inverse stay as it is, Derivative of this, again there is a power, so power will be written in the start, 1 minus x square power minus 1, and derivative of the function without power, plus 1 minus x square minus 1 by 2, and then derivative of cos inverse x, again minus 1 over square root of 1 minus x square. Okay. Now this is equal to minus 2. We will keep on solving it slowly. Check that this is written as it is. Minus 1 by 2 still written as it is. And its power minus 1 by 2 and minus 1 added up to minus 3 by 2. Okay. So derivative of 1 minus x square 0 minus x square derivative is 2x according to power rule. Power in start, power minus 1. So power in start, power minus 1 will become 1. No need to write that one. Okay. Plus 1 minus x square whole power minus 1 by 2. And this one is minus 1 over 1 minus x square square root. Okay. After this step, we can see that this can be cancelled with this. This 2 can be cancelled with this one. And minus 2 cos inverse x, okay, can be written as it is, but this whole minus and minus will change to plus sign. Means this minus and this minus will change to plus. Okay. Cos inverse of x we will write as it is. And I will shift this now in the denominator, 1 minus x square, so its power will become plus 3 by 2. Okay. Plus, I shift this also in the denominator, this negative 1 over 1 minus x square. This one is coming like that, and this one is already over here, 1 minus x square. It's okay. Then this is equals to minus 2 cos inverse of x over 1 minus x square. I can write it 1 and 1 by 2 separate. 1 minus x square separate. Minus plus minus minus 1 over 1 minus x square. Okay. Here we can say this is also as y2, or we can just make it a little bit simplified, because in the proof section if we will check properly, otherwise still here or after taking the LCM or making the denominator same, our second derivative is perfectly done. But we have to check this proof also. In this proof 1 minus x square is there, so can we take 1 minus x square common and give it to this? Okay, so what will left over here, that will be, I'm just taking 1 minus x square common from here, from both. Upper one is minus 2, and here left cos inverse of x over 1 minus x square, and this is left minus 1. Okay, now I can give it to this one. On this side it will multiply. y2 is equal to minus 2 times cos inverse of x over 1 minus x square minus 1. At this step, you can write its value and minus x value in the given equation. But if you see properly that your second derivative is done over here till here, and we are just arranging to make our proof. Second derivative is almost done till here. Okay, we are just doing the arrangement to take our required relationship. But if you see 1 minus x square y2, it's done. So this can be changed, because this clearly, this portion is equals to y1. If you see over here, this portion, if you multiply minus 2 inside, it will equals to minus 2 multiply minus 2 cos inverse of x over 1 minus x square minus minus plus 2. Now this portion exactly is this one. So we can replace it by y1, yeah, y1. I think I skip this x over here, writing this x, 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 x. So this portion I am writing this x outside. Okay, this portion clearly changes to first derivative y1, and x is staying here, and this is plus 2. If we check properly, our proof is done. It's going very close to our proof that 1 minus x square y2. So formation, required formation we can receive just if we make a little changing, bring this term over here and interchanging their position. Also in product you can exchange the positions, minus it will become negative x y1, this also shift here, it will become minus 2 equals to 0. So our required formation is done, so hence proved. Okay, so now we will go to the next part. Exactly not in the same way, but again one more part I want to do with again the second derivative. Okay, in which again you have to find out the second derivative with the trigonometric function also, and with the logarithmic function also. Okay, you have trigonometric function, you have log of x, you have trigonometric function, and the angle is possessing log of x, natural log of x, and then you have to make a proof with the second derivative. This you have to prove. For this, what you must know? You must know the derivative of cos, you must know the derivative of sine, and you must know the derivative of log of x. Okay, now derive it, differentiate it with respect to x this side, and differentiate with respect to x on this side. A cos of natural log of x plus b sine of natural log of x. In my previous video also I told many times, when the coefficient is there you can write coefficient outside, and then derivative of the function you can write derivative of cos of natural log of x plus b constant derivative of sine of natural log of x. I just give the differentiation to first function and the second function same in the addition form. Okay, because if you are applying the derivation on a polynomial with so many terms, so each and every term will be differentiated separately. Okay, so derivative of the cos function and derivative of the sine function we will write. Now a is as it is, derivative of cos we have to keep in mind, that is minus sine. Derivative of cos is minus sine of the same angle. Derivative of cos is minus sine of the same angle, and then derivative of the angle we have to take. Okay, same is the case plus b, derivative of sine is cos of the angle and derivative of the angle. Okay, so now it will be equals to minus sine, I will keep outside, a sine of natural log of x as its angle, derivative of log x is 1 over x, and then derivative of its function x is 1. If it is other than x, you have to write the derivative of that function, but if it is x, no need to write because the x derivative is 1, plus b cos of natural log of x 1 over x. Okay, so taking x common, better to take x common and then shift on the other side. Okay, if I'm writing x common here, then minus a sine of natural log of x plus b cos of natural log of x, and this is dy by dx. Shift x over there, x times dy by dx equals to minus a sine of natural log of x plus b cos of natural log of x is ready. If you need to find out the first derivative is done till here. only. Okay, but if you're going to the second derivative, this I'm doing just to go to the second derivative and to see that x dy by dx is matching my this required statement also, x dy by dx. Okay, so we have to go slowly to this formation also, keeping this formation in the mind. Now what we have to do, we have to take the second derivative of this. Okay, so take the derivative on this side and take the derivative on this complete side. Okay, that one is x dy by dx minus a sine of natural log of x plus b cos of natural log of x. Go slowly to your next derivative. Okay. Okay, so here if we are taking the derivative of this function, what is this? This is two functions, so we have to apply the product rule for taking the derivative of this side, and this side we have to take the derivative of the first function, it's a single function, and second function also, it's a single function, because a and b are constant number. If you understand my video, please like and share in your groups and subscribe to my channel. Okay, coming back to our point, x first function will stay as it is, derivative of the second function, that is dy by dx, plus dy by dx as it is, derivative of the first function, that is x. I apply the u into v type or product rule over here. Now derivative minus a, derivative of sine of natural log of x, plus b, derivative of cos of natural log of x. So what I can do here, this is x as it is, derivative of dy by dx is second derivative, plus dy by dx stay as it is, and dx by dx will become 1 equals to minus a, what is the derivative of sine? Cos of angle, and then derivative of angle, that is natural log of x, plus b, derivative of cos is minus sine of angle, then derivative of angle. Okay, so here it will become as it is, we will write x, d square y by dx square plus dy by dx equals to minus a cos of natural log of x, and its derivative is 1 by x, again minus b sine of natural log of x, and its derivative again 1 over x. This x again I am taking common and then shifting on this side. Okay, so in the single step I take common and shift on this side, it will multiply over here with the previously present statement, plus dy by dx, and from here I take minus also common. So what I will get over here, a cos of natural log of x plus b sine of natural log of x left here, because x I take common and shift over here. Here it is dividing, on the other side it will multiply to the whole statement. If we see properly, this is becoming y. This is equal to our same statement from where our question was started, the value of y, exactly the same value of y. So I can replace this, multiply this inside, x times dy by dx. Okay, and this is minus y. Can I shift this over here? It will become then plus y equals to 0. So our required formation which is asked in the question, that is done over here. So thank you so much. If you like my video, please share in your groups and subscribe to my channel. Thank you so much. Allah Hafiz.